Hello friends, welcome back. In this tutorial we will study about connecting devices. So first of all we will study about passive hub. So what is this passive hub? This passive hub is just a connector and it connects the wires coming from different branches. It does not have the ability to amplify or regenerate any incoming signal, right? And this device passive hub, it operates below the physical layer. Now the next device is repeater. Now see what happens in repeater. This device repeater, it operates only in the physical layer, right? And this device repeater receives a signal before it becomes too weak or corrupted, and then it regenerates the original bit pattern, and after that this device repeater sends the original signal. This device repeater does not connect to LANs, right? It connects two segments of the same LAN, right? So this device repeater, it does not connect two LANs. It connects two segments of the same LAN, right? And what happens, this device repeater, it acts as a two-port node, right? It acts as two-port node, right? It receives the frame from any of the ports and then it regenerates and forwards that received frame to the other port, right? And this device repeater, it does not amplify the signal, it regenerates the signal, right? It regenerates the signal, it does not amplify the signal. And what happens, the location of this device repeater on a link must be like that a signal should reach it before any noise changes the meaning of any of its bits, right? Now the next device is active hub. So what is this active hub? An active hub is actually a multi-port repeater, and it is normally used to create connections between stations in physical star topology, right? And it operates at the physical layer. Next device is bridge. Now see what happens in bridge. This device bridge, it operates in both the physical layer and the data link layer, right? As a physical layer device, it regenerates the signal it receives, right? As a physical layer device, this device bridge, it regenerates the signal which it receives, right? And as a data link layer, it can check the physical address, that is the MAC address of the source and destination, which is contained in the frame, right? Now this device bridge, it has filtering capacity, right? It can check the destination address of a frame and decide if the frame should be forwarded or dropped. If the frame is to be forwarded, then the decision must specify the port, right? If the frame is to be forwarded, then the decision must specify the port, right? So what happens, a bridge has a table that maps addresses to ports, right? It will be clear after this example. Now see in this figure, right? In this figure you can see that two LANs are connected by a bridge, right? So what happens, if a frame destined for station X arrives at port 1, right, then the bridge will consult its table to find the departing port, right? Now what happens, according to its table, the frame for station X will leave through port 1, right? Therefore what happens, there is no need for forwarding and the frame is dropped, right? But if the frame for station X arrives at port 2, right, if the frame for station X arrives at port 2, then what will happen? Then the departing port is port 1, right, and the frame is forwarded, right? So in this example we have considered this two-port bridge, right? In this example we have considered only this two-port bridge. In reality a bridge usually has more ports, right? Now the next device is router, right? So what happens in this device? This device operates at the physical layer, data link layer and network layer, right? And what this router does, this router routes packets based on their logical addresses. And a router normally connects LANs and WANs in the internet, right? And it has a routing table. This router has a routing table that is used for making decisions about the route, right? And this routing table are normally dynamic and they are updated using routing protocols. So about routing protocols we will study later in separate tutorials.